You ever send a text or an email and just stop and think about how it arrived, like almost instantly halfway across the world? I mean, it really feels like pure magic. But behind that magic is this incredibly precise 7-step journey that every single piece of your data takes. So let's pull back the curtain on this hidden world and follow a message from start to finish.
Okay, so picture this. You've typed out your message, you've found the absolute perfect emoji, and you tap send. What is actually happening in that split second between your screen and your friends? It's not just a straight line. It's actually a pretty complex, layered adventure.
And the answer? The secret is this number, 7. Your message is about to travel through 7 totally distinct layers. It's a system called the OSI Model, and you can think of it as the universal rulebook that lets any 2 devices on Earth, no matter who made them or what software they're running, have a perfect conversation. All right, so our journey begins in what are called the upper layers. This is where your message gets all suited up and prepared for its big trip across the digital universe. It's got to get ready, right?
So, our journey starts right here with you at layer 7, the application layer. This is the only part of the whole process you actually see and interact with. It's your web browser, your messaging app, your email client. When you type that message, you're literally knocking on the front door of this entire system.
And this is a great way to think about it. This layer is basically doing just that. It's taking your message, your text, and putting it into a digital envelope. It knows what you wrote, and it knows who it's for. Simple as that. Okay, moving down one level, we get to layer 6, the presentation layer. Now, this layer has 2 really important jobs. First, it's a universal translator. It takes your message and converts it into a standard format so that any device out there can understand it. But its second job? Well, it's even more important. Security. This is where encryption happens, scrambling your data so nobody can snoop on it while it's in transit. Exactly. It's turning your message into a secret code. You actually see this layer in action every single day when you see HTTPS in a web address. That little S stands for secure, and it's your sign that layer 6 is on the job protecting your information.
All right, so our message is translated, it's coded. Now we need to actually open a line of communication. And that's the job of layer 5, the session layer. It works kind of like an old school switchboard operator. It creates a stable, dedicated connection, a session, between your device and the receiver before any data actually gets sent. And this is so important for making sure things are reliable. This layer makes sure that connection is solid, it keeps it alive while you're maybe downloading a file, and then it politely hangs up when you're all done. It's what stops your digital conversations from getting cut off mid-sentence.
Okay, our message is prepped, and the line is open. Now for the really fun part, the action-packed part of the journey, navigating the massive, tangled web of the internet itself. We're heading into the lower layers. Welcome to layer 4, the transport layer. See, sending a huge message all in one go is super risky. If one tiny piece gets lost or corrupted, the whole thing fails. So this layer is like a smart traffic director. It chops your message up into smaller, numbered pieces called segments. It's like sending a book chapter by chapter instead of all at once. Way safer. But wait, how does your computer juggle a web browser, a video call, and an email app all at the same time? Well, that's where the port number comes in. It's like an apartment door number. It tells the receiving computer exactly which application, which door, this piece of data needs to go to. And here at layer 4, our message has 2 ways it can travel. On one hand, you've got TCP. Think of TCP as the careful, meticulous courier. It checks and double-checks that every single segment arrives, and in the correct order. This is absolutely essential for things like emails or web pages. Then you've got UDP. UDP is the speed demon. It just sends data as fast as possible and doesn't worry about checking for errors. This is perfect for live video or online gaming, where a single lost pixel isn't a disaster, but lag definitely is. All right, our segments are ready to go. Now they need an address. And that's the whole job of layer 3, the network layer. It takes each of those segments, wraps it into something called a packet, and stamps it with the most critical piece of info for its global journey, the destination IP address.
And that analogy on the slide, it's perfect. Just like a letter needs a full street address to get across the country, a data packet absolutely needs an IP address to find its way across the vast internet. This layer is basically the internet's global postal service, and its job is to figure out the best possible route for each and every packet.
But here's the thing. The internet isn't one single road. It's a series of short hops from one device to the next. That's where Layer 2, the data link layer, comes in. It manages just the very next hop in the journey. It wraps the packet into a frame and gives it a local address, called a MAC address, for the next immediate device in the chain, like, say, your home Wi-Fi router.
This distinction is so important, so let's make it clear. The IP address is the final destination city. The MAC address is just the address for the very next building on the street, the next stop on the way. Layer 2 is all about getting the data successfully from this point to the very next one.
And finally, we hit rock bottom, literally. Layer 1, the physical layer. This is where all that neatly packaged digital information gets turned into a real-world physical signal. It becomes electrical pulses buzzing down an Ethernet cable, tiny flashes of light in a fiber optic line, or radio waves for your Wi-Fi. This is the actual hardware, the stuff that makes the internet go.
So let's recap that whole packaging process, right? Your message was broken into segments, then each segment was put into a packet with its global IP address, then each packet was put inside a frame with its local MAC address for the next hop, and finally that whole frame was converted into a physical signal. It's like a Russian doll of data, with a new layer added at each step.
So after hopping across who knows how many routers and cables, our signal finally arrives at its destination. But right now, it's still just a bunch of coded electrical pulses. So now, the entire process has to happen in reverse to rebuild our hero, the original message.
The receiving device catches that physical signal and just perfectly reverses the entire process. The frame is unwrapped to find the packet inside. The packet is opened to get the segment. And once all those segments have arrived, TCP puts them all back in the right order, and voila! Your original message is reassembled, ready to be read.
So you might be thinking, wow, okay, that is a lot. Why all this trouble? Why 7 complicated layers? Well, it's because this system creates order out of what would otherwise be total chaos. It allows a company that makes routers to focus only on their layer and a company that makes an app to focus only on their layer, and they both know it's all going to work together seamlessly.
And here it is, the entire journey, all in one place. We started at the top, Layer 7, where you write your message, just like putting a letter in an envelope. It got translated into a secret code at the presentation layer and was given a clear phone line at the session layer. Then came the heavy lifting. The transport layer chopped it into pieces, the network layer gave it a global street address, the data link layer told it the very next building to go to, and finally, the physical layer put it on the actual roads and airwaves. This invisible, brilliant architecture is what makes our entire connected world even possible. So the next time you tap send, just take a second and appreciate that incredible 7-layer journey. And it leaves you with a final thought. Without this strict, layered rulebook, what would our digital world even look like? Probably just chaos. A mess of incompatible devices, totally unable to speak a common language.